Alright, let's come back to the lecture. 2.1 Principles of Network Applications. Let's first talk about the architecture. There are three options. We'll talk about content distribution network later in the chapter. So first is client-server, second, peer-to-peer. And there's actually a third one. Some applications actually implement using this client-server P2P hybrid architecture. You'll see an example in a little bit. So, client-server architecture. So, what you're seeing here is these are server, these are clients. All right? So the characteristic of the servers are these. These are end systems that are always on. If you think back, when you're working at PA1, no matter whether it's the day, it's the night, or it's the midnight, hey, that workstation 140.112.42.161 is always running. Okay, and it's on a permanent IP address. I just recited the IP address. I don't want to, do it again. Always on. Permanent IP, that is the major characteristic of these servers, servicing end systems. And sometimes when the service is really, really large, okay, so for PAs, you just need one server. For example, if you are using a Gmail account, emailing me, yeah, Gmail servers, it actually takes a whole data center. Inside the data center, there are often hundreds of these server machines, hundreds of these workstations. It might take a huge data center in order to scale, to make sure that it can serve billions of users and sending emails simultaneously. All right, so that was server. Usually very big machines, expensive machines. Clients, on the other hand, yeah, of course they communicate with the server, but unlike servers always on, clients are often more intermittently connected. So car here, having a pad, as it travels through, 4G connectivity might be weak or strong and weak again, and disconnected and strong again. Yeah, that is very unstable, intermittently connected client. And very likely, you guys are connecting to the internet using your smartphone through various IP addresses. It actually depends on where you go. On campus, if you are connecting to NTU PEEP, then NTU PEEP give you one IP address. That's going to be starting from 140.112 because you are on campus of NTU. As you walk out to have lunch, then it might be running on 4G. Then it really depends on who's your phone service provider. Then it could be operating on something like 72 dot something dot something. All right. So as you go the whole day, you might be using a handful of these IP addresses. And clients do not communicate directly to each other. Rather, they connect to the servers. Now, those clients who connect to each other are then working in this alternative architecture, the peer-to-peer architecture. So you see the elements involved here in a P2P application are simply weak end systems. We're not seeing these big machines involving in a P2P application. Yep, sorry, in P2P architecture, well, maybe I don't need to say sorry that much. Yeah, back to the lecture. In P2P applications, there are no longer anyone being always on. All right, all of us are clients, but we are clients trying to help each other. Okay, people helping people. So we have arbitrary end systems directly communicating to each other. So the peers are helping each other, requesting help from each other, request services from other peers, and other peers provide services in return. And the fact is that this peer asking for the service might also be requested by other peer here for services. So again, people helping people. So these guys helping each other. These guys helping each other. And again, helping each other. What's really nice about communicating this way or providing services this way is this. Self-scalability. You see, because if I join a P2P network, let's assume Polly is this laptop. Okay, I can request services from this desktop. Okay, so let me see. I want this web page, for example, and let's assume that the web is P2P. What's going to happen is, hey, this guy here or this guy here can also be requesting the web pages that I have already downloaded because I have a copy of it, right? So why don't I provide the web page to other guys? So that's called the P2P. I give you a hand, and you being helped by me manage to finish PA1. Then you can go on and help other teams for the PA1. So I'm not saying that you want to copy each other's assignments, but just what I'm saying. So you guys teaching each other or helping each other to find out what is the username and password for the team account. Yeah, that's P2P helping. There's a self-scalability in terms of whenever I join the network and asking for services, I'm also providing my capacity to help others for the service. So new peer brings new service capacity as well as new service demands. So yeah, I'll be requesting services, I'll be asking for resources, but I'm also paying back with my resources. So many people like P2P, especially young people like P2P because it's kind of fair. Okay. So I mean, if I have resource, right, why not just help each other? All right, so peers in a P2P network, unfortunately, needs to be intermittently connected. It's going to be very hard. You guys sticking to the same IP address. So the IP address is going to be changing. So one of the big headache designing a P2P application is this. Management of the peers, right? So if this is Polly, and I'm running suddenly from IP address number 1 to number 2, there needs to be some sort of directory such that it maintains what's my current IP address. So my friend here will be able to contact me smoothly. Okay. Ended up, we have a complex architecture using P2P in the end. You'll see later the BitTorrent example, how complex it can be. Now the third kind, the hybrid client-server and P2P. Oh, okay, this is actually a very good example to talk about how P2P can be complicated, and some application chooses a hybrid architecture such that the complicated part, the directory lookup part, the IP address lookup part, okay, is client-server based. So in Skype, okay, so Skype is actually hybrid P2P and client-server. It actually maintains centralized servers, and in fact, multiple of them, so that when we are logged into Skype, we see this directory of our friends that we might need to make a call to. Yeah, well, once we click on the friend's head, what it does is the central server here would look up what is the current IP address of your friend, and then inform your program, yeah, the program sitting on your laptop or sitting on your mobile phone, what is the IP address that you need to call to directly. Okay, so you're calling your friend's IP address directly. So the calling part is P2P, but the lookup part, the part that you need to look up the IP address of your friend, that part is client server. Interesting, isn't it? All right, so that's the architecture of applications. Let's talk about process communication. So we do have sometimes, especially applications running in the client-server model. We have the client process, we have the server process, and these processes we need to communicate. P2P applications, peer-peer processes, they could be the same program, but they also need to communicate. So processes running on a host in the internet will then have to communicate with other processes also on the internet. Now, if the two processes are running on the same computer, there are other ways of doing the communication. If you know operating system well, you know that there are sometimes calls you can make, just like command line function calls we often use, such as cd, mkdir, creating directories. So there are command line functions you could call that allow you to do this inter-process communication. You don't necessarily send messages. Instead, you call a function and provide certain parameters. Okay. Now, on the internet, however, for processes that are sitting on different hosts, then we do need to exchange messages. All right. So, client and server, each will have its own process. The client process oftentimes is the one initiating communication, because server is always just sitting there, right? Server does not say, hey guys, would you like to see this web page or not? No. Yeah. Clients issue requests for a page. Server sitting there waits for a connection request, waits to be connected, waits to be contacted. So one is passive, the other needs to be active. Okay. So in client-server model, this is very obvious. In peer-to-peer model, however, one is actually actively probing another peer. Well, they are sitting there, but hey, it's barely satisfying the definition of a server. So we don't call a peer process a server process. And because a peer also provides services, so we don't call the peer process a client process. So therefore, we call these P2P applications processes the peer process, right? So applications with the P2P architecture will have peer processes. In these peer processes, we'll be implementing both the client and the server functions.